Hey guys, in this little video I'm going to be discussing marginal abatement costs, marginal damages, and bringing them together into this one big pollution picture. This is for an environmental class. I'm not going to do a lot of math here. I'm just going to try to give you some intuition behind this graph, okay? So, marginal abatement cost. First of all, what is abatement? That word is not something we usually say. Well, abatement is the process of reducing your pollution. Okay, so to have pollution abatement is to go a little greener, to get a little cleaner. All right, now let's look at our graph. What do we have? Let's see, dollars, we're measuring everything in dollars, go figure, we're economists. And quantity of pollution. How much pollution are we emitting? Now, this can be a firm dumping toxic waste. This can be a firm having greenhouse gas emissions. This is pretty generic stuff, okay? Just pollution in general. Now, presumably, there's an amount of pollution that our firm wants to do if it was in an unregulated market. Okay, so maybe that's like down here. And the book I'm currently using calls this Q max, although I usually call this Q market. I don't really care, whatever you guys want to call it. And this is how much pollution is going to happen if there's no regulation and no incentives for the firm to change their behavior. But what if we as a society, let's not even get into the societal question, what if the firm wanted to reduce its pollution, either out of some environmental goodness or just because the government's forcing them to? To reduce pollution, pollution abatement would be to move from Q max to some lower Q. Abatement is to decrease your pollution, which would be a shift left along this curve somewhere. Now, when you first start, the first teensy tiny bits are pretty cheap. You turn off the lights a little bit longer, or you change your thermostat by a degree or something. Like, you don't have to do much to make teeny tiny changes. And firms will usually try their cheapest pollution savers first. And that's just profit maximizing behavior. We'll do the cheapest costs first. So as we decrease our pollution, we take advantage of low-cost opportunities first. And then if we have to reduce pollution more, we've already exhausted the lower-cost stuff, so we've got to go to a higher cost. And then if we want to decrease pollution even more, we have to start making more and more drastic and costly changes. So that the more we want to reduce pollution, we go from, hey, we turned out the lights for an hour, to, hey, we're like, to get way over here, we're like rebuilding our factory with new technology that's all solar based or something. Okay. There are small changes the firm can make near its market outcome that aren't very costly. And those changes we usually assume are getting more costly the more we reduce pollution. So as we abate, as we reduce our pollution, we expect further reductions to get more expensive. Hence this downward sloping MAC curve, because abatement is going that way towards less pollution. More abatement, more cost. All right, I hope that helps. If not, well, I'm not sure how much this video is going to do for you because I'm already moving on. Marginal damage now. The other side of this picture. This is just the idea of the externality. The pollution is doing damage to the environment or to society in some way, and we usually assume that this is an upward sloping relationship. Part of that is because the environment, if we only pollute a little bit, is usually pretty good at cleaning up. For instance, trees can absorb some carbon dioxide, and that's how trees get bigger. So the trees can absorb some of our pollution, and so we could pollute a little bit, and it would do zero or little damage to the society or to the world. But as we increase our pollution, we will start to overwhelm the environment's ability to clean itself and start doing damage. And then as we pollute a lot of it, those damages might start getting bigger and bigger and bigger. Yeah, I think that's about it for that one. Hope that helps too. Moving on. Let's combine these into the same graph now. Anytime an economist draws a graph that has a little X in it where two lines cross each other, you can bet we're going to call it the optimal something. Well, here I'm calling this the optimal level of pollution. And here I'm saying it's the optimal marginal damage and optimal marginal abatement cost. So why is this an optimal point though? Let's dig into that just a little bit. Let me get rid of those just so it doesn't distract us too much. Let's talk about it. And let's start with ourselves over here at Q max. Okay, we'll start with where the market wants to be. If you're over here, and our firms aren't debating anything, they're just doing what they want to do. The marginal damage up here is higher than the cost of reducing that pollution. The damage of that pollution is more costly than the cost of reducing the pollution. I know I just said that twice. That's because it's important. That means we've done too much polluting. The costs, the damage, outweigh what it would cost to get rid of the damage. That's just inefficient. So if the marginal damage is greater than the abatement cost, that means abate more. Because when we move to the left, we will find ourselves at a point with less damage. And although the abatement cost has risen, it hasn't risen by as much as the damage fell. And so society as a whole is better off. Now, carry that argument on, and we'll find ourselves at this point. At that point, the cost of abatement is equal to the damage being done to the environment. The firm at the margin is saying it is the same cost for the big picture for us to reduce pollution or keep polluting. So that's going to be our optimal point. So what happens if we go further? What if we tell them to abate all the way? And let's kill pollution and put it all the way over here or something. Well, we will find ourselves at a point where the marginal damage to the environment is really, really low. And that's in dollar terms. But the cost of getting there is super high. And from a cost-benefit analysis, the amount of damage we've reduced is less than the extra costs that we've created. To summarize some of this, over here I'm going to say that the MAC is too high because it's greater than the marginal damage. The cost that we're forcing onto the firm is greater than the damage they're doing to the environment. Going to absolute zero emissions throughout our whole economy is kind of pointless because at least some amount of emissions can be absorbed by the trees, for instance. And then, I don't know exactly where we want to line up, but, well, actually I do. We want to line up here at this optimal point. But yeah, if we go too far, we're doing all this extra costs for no good reason. Whereas over here, with too much pollution, or not enough abatement, the marginal damage is too high. We haven't abated enough, and the damage we're doing is less than the cost of reducing the damage. Where's the sweet spot? Right here. At that sweet spot, we've balanced the cost of cleaning up versus the benefits of cleaning up. And that's where we will find the efficient outcome. So, I hope that's helpful, guys. I know it was short. Actually, I guess it wasn't that short. I know we didn't math it up or anything, but I feel like at this point, setting a couple of lines equal to each other, we're good at that. I just wanted to explain the abatement and how it works backwards on the pollution graph, because this is pollution, whereas abatement is reducing pollution, so it moves left, and so it helps to be able to explain what's going on here. Hope it worked. If not, too bad. Good luck, guys. Thanks for watching. Peace out.